Okay, we're starting out this first section, 3-2, solving inequalities using addition and subtraction. Take a look at what this basically looks like. What we've got, just like equations, we're going to be making equivalent inequalities by using some property of equality. Addition property of equality, for example, says that if x minus 1 equals 3, then adding 1 to both sides will give an equivalent equation, x equals 4. They both have the same solution. So the same thing holds for addition with inequalities, okay? If you have a greater than b, then adding c to both sides will still make that side greater. Okay, if a was less than b, adding c to both sides would continue to make that side less. Okay, so for example, if 5 is greater than 4, then 5 plus 3 is greater than 4 plus 3. Makes sense, yeah, etc. Yeah, very straightforward. So let's see how we apply this. All right, so what are the solutions to x minus 15 is greater than negative 12? They want us to then graph it when we find the answer. So we start here with the original inequality unchanged at the start, and we do that like we've been doing with equations, where you write what was there and then follow it up with the change that you're making, in this case plus 15. When you simplify this, you get x. When you simplify this, you get 3. So what we have here is an equivalent inequality for this, which is x is greater than 3. How do you graph that? You go to 3, and you don't fill it in because it does not say or equal to. So you just put a circle there, and we want all the values where x is greater. So we go above that, like that. Yep, that's it. Try got it problem on your own. You're going to do the same thing, which is solve it and then graph it. Good luck. All right, this is asking you how do you check that the final inequality is actually all of the solutions for this. Okay, now unlike an equation where there's one answer and you can just plug it in and see if it works, you can't do that because there's infinitely many solutions. But there is a way to do this. What you can do is you can say, I need to verify that the endpoint is correct by plugging in 3 into the original equation, or the original inequality, and what I should get is the same number on both sides, right? It won't be true in this case because it doesn't say r equals, but all you're looking for is, do I get the same number on both sides? And if you put 3 minus 15 here, you get negative 12, and negative 12. That means the endpoint is correct. Now, which side of the value 3 are the solutions? So what you have to do is you need to pick a value that's on that side of it. X is greater than 3. So put in some number greater than 3 and see that it's true. Okay, we're going to do this in problem 2. So what do we got here? What are the solutions of x is greater than or equal to x minus 3? Graph it and check. So the first thing we need to do is we need to solve this by writing the original equation and then adding 3 to both sides. And we get that 13 is greater than or equal to x. Okay, so what's the endpoint? The endpoint is 13. We do fill it in because it says r equals. And x is on the small side, so we got to go lower than that. Okay, now how do we check it? Well, first we're going to plug in 13. When we plug in 13, do we get the same thing on both sides? Yes, that means the endpoint is correct. And now we need to pick a number that's less than 13, because that's what it says, these values less than 13, so let's say 12. So we take the original inequality, we plug in a number that's less than 13, because that was what it said, and it does work out to be a true statement. Okay, that's how you do it. So try it with this got it problem. Do the proof as well. Okay, not really anything new with this one, except that we could also do it with subtraction. That's the big idea. If you have some inequality, the left side is greater than the right-hand side, then subtracting the same amount will give you the same equivalent statement that the left side is greater than the right-hand side, etc. Okay, it's also true for or equals. That's all that says. So let's try a problem. Okay, so here's the problem. T plus 6 is greater than negative 4. Graph the solution when you find it. So we subtract 6 from both sides, we get t is greater than -10. So we have an open circle here because it doesn't say or equals, and t is all the values greater than -10. So you go from there up. Yep. And do we need to do a proof on this? Well, you should always be reading the problem and seeing what it's asking you to do. Okay, what are the solutions it's asking for? So that's this. And then graph the solutions. That's this. Do what the problem asks of you. That's the key to doing this. Okay, let's see how you do with the got it problem. Okay, so this lesson check is for the first part. This is not the end of the video. You could do these lesson check problems to see how you did, and particularly maybe just, if nothing else, focus on these first four. But if you are wise and you want to really get a good handle on all of it, you'll read all these problems and do all the ones that you can before you check your answers. Okay, do that. Good luck. After you restart it, you're going to see the next lesson, so you're going to keep watching. All right, so now we're moving to doing the same one-step problem solving here, inequalities, but we're using multiplication and division. Let's see what this looks like. Okay, so here is the idea. When c is greater than 0, it's just like a normal problem where if you say the left-hand side is greater than the right-hand side, then multiplying both sides by the same will keep it the same situation, okay? Now, the trick with this and the big idea of this lesson is, I guess what I would say is that the one most difficult thing to keep in mind is if c is less than 0, meaning you're multiplying by a negative number, what's going to happen is the inequality will flip. If right now the left-hand side is greater than the right-hand side, and you multiply by a negative, then the right-hand side is now going to be smaller. The direction of the inequality flips, okay? And that's true for all inequalities where you're multiplying by a negative number. Keep that in mind because it's definitely going to be wrong if you don't. Okay, this is just a quick explanation of why it works. Multiplying or dividing each side of an inequality by a negative number changes the meaning, changes what is less and what is more. You need to reverse it. So if 3 is greater than 1, which it is, and you multiply both sides by -2, what you get is -6 now compared to -2. And which one's greater? Well, now the one on the right is greater, okay? So you're just reversing it. It's not exactly an explanation of why, but more just a demonstration that that's true. So let's try a problem. All right, so if you're multiplying by a positive number, and of course in this problem, what are the solutions to x divided by 3 is less than -2, which you're going to graph the answer when you're done. X is being divided by 3, so you need to undo that with times 3, both sides. Notice what they did. They wrote what was there in parentheses, multiplying by 3 out front. And that cancels that. You get a -6 here. Since it's a positive number here, you're going to keep the sign the same. Nothing changes if you multiply or divide by a positive number. Okay? And notice the number that you're dividing is negative. That's not the point. It's not that there's a negative anywhere. It's the number you're dividing or multiplying by, in this case, multiplying. Okay? So x is less than -6. Does not say or equals. So you do not fill it in, and then it's everything less than that, so you go that way. Okay? Try it with your got it problem right now. Okay. Now, what if you are multiplying by a negative number? What are the solutions to -3/4 w is greater than or equal to 3? You're going to graph it, and you're going to check your solutions. This is a great thing to check to make sure that you've correctly adjusted for the negative. So remember, when you're going to clear a fraction, that is the coefficient that you're trying to get rid of. It's being multiplied by -3/4. You multiply by the reciprocal. The reciprocal still has the same sign. It's just flipped over. So you multiply by negative 4/3, because remember, negative times negative will give you the positive W that you want. So you multiply by negative 4/3 both sides, that 3 cancels that 3 out, and you're left with negative 4. However, at the exact point where you multiply by a negative, that's the point at which it switches. As soon as you put this on there, multiplying by the negative, everything changes to the opposite direction, or the sign does rather. So now you've got this, W is less than or equal to negative 4. So you go to negative 4, you do fill it in, and W is less than, so you go less than, okay? Now, how do you check it? Well, what you want to do is check the exact value itself, negative 4. And you could write it as an equation and check it, plug in that negative 4. It should work out exactly equal, which is what you want, okay? And the equal here has nothing to do with whether this says or equals. That's not really the point. The point is just you're checking to see that if the end point is correct, you're going to get the same thing on both sides. So that's where you want it to be equal, even though it's not an equation. Okay. And then what do? Well, now that you know that the end point's correct, we need to check values that are less than it, because that's what you have it saying. And by the way, if you didn't flip it, it would still be equal if you had the right endpoint. It would just be pointing in the other direction. So what you need to do is check, is a number that's in this shaded part a solution? So they take the negative 5, which is part of the solution set, they plug it in, and when they calculate it out, they get 3 3/4 is greater than or equal to 3, right? And that's true. Now, you might notice this if you're a sophisticated thinker, that this 4 on the bottom could perfectly cancel out a whole number if it was a multiple of 4. So instead of picking negative 5, you could pick negative 8, which is still on that side of it, so that's fine. And if you put in negative 8, that 4 and that 8 will perfectly cancel to give you a whole number. That might make it easier for you if you understand what I said there, okay? But either way, what do you do to check it? You check the endpoint by setting it as an equation, and then plug in that endpoint number, and it should work out to be true. And then you do it again with the original inequality, plugging in one of the numbers that's in the shaded region. Any number that's in the shaded region will be fine. And it's got to work out to be true. Here's your got it problem. See, I do. Okay, so this essentially says that division is similar to multiplication for inequalities. And meaning if you divide each side by a negative, you need to reverse the direction of the symbol. Okay, and here's just the math that says if C, the number you're dividing by, is positive, then it's going to be pointed in the same direction as it was here, it will be here. Okay, and if it was pointed this way, it will still be pointed that way because C is a positive number. But what if it's negative? If C is less than 0, that means negative numbers. Then if it started out like this and you divide by C, the negative number, it's going to change direction. Here, if you started out in that direction and then you divide by C and it's negative, it's going to change direction, okay? That holds true for if it says or equals as well. Let's try one of those. So what are the solutions of negative 9y is less than or equal to 63? Graph those solutions. It says solutions because remember in inequalities you get an infinite number of numbers all in the shaded region that are making it true. So how do you do it? You write the original problem down. At the exact step where you divide by the coefficient, which in this case is negative, it switches direction. Notice that? That's going to be, if you mess up one thing in this lesson, it's probably going to be the you forgot to switch, or you switched and you shouldn't have. Because remember, it's only if the number that you're dividing by or multiplying by is negative, that's when you switch, okay? And you get simplified, you get y is greater than or equal to negative 7. How would you check the solutions? Well, you would put negative 7 into negative 9y equals 63 and see if it works out to be equal. And then you would take something that's greater than negative 7 and you would plug it into the original inequality and it has to be true. Plugging in the negative 7, saying it's equals and plugging in the negative 7, that'll check that the endpoint is the right endpoint. Picking something greater than negative 7 will check that you've shaded the correct side of that endpoint. And here graphed, you say negative 7, it's included because it says or equals. That's the endpoint, so it's filled in. And you want all the values greater than that, so you do that, okay? One quick, easy way to do it is to check 0. If 0 is on the side that you're shaded, then if you plugged in 0 in here, it's easy because -9 times 0 is 0. Is 0 less than or equal to 63? Yeah, 0 is less than 63. That's good. Another way to use 0 would be to say if your arrow is pointing this way, then plugging in 0 should make it false. Okay, so you can use it that way as well. This is your got it problem. Solve it, graph the solutions. Good luck. All right, this is an excellent set of lesson check problems to do that shouldn't really actually take you that long. These are quick ones. You might want to do this one to ensure that you've really got this part down because it seems simple but can catch you if you're not being really closely attentive. Anyway, good luck with this.